They are the workhorses of electronic communications. Every time you talk on the phone or go on the internet, what you say or type travels to its destination through hair-thin glass fibers, fiber optics. Creating a fiber optic starts with a large glass tube. First, they're unwrapped. Then they're submerged in a corrosive bath of hydrofluoric acid. This removes any oily residue. Then the tubes are set into each end of a lathe. As the tubes spin, they're heated with a hydrogen-oxygen flame. When the glass turns white, it's getting close to hitting peak temperature. At 2000 degrees Celsius, the two tubes fuse together. They put this new longer tube into another lathe. As the tube spins, a mixture of chemical gases are injected inside, while a traversing burner heats everything up. The gas mixture contains liquid forms of silicon, an abundant chemical element found in nature, and germanium, similar to tin, and used as a semiconductor in transistors and other electronic devices. As the gases heat, they undergo a chemical reaction that leaves a white soot on the inside of the glass tube. The heat fuses the soot, forming what will eventually become the core of the optical fiber. The glass tube itself will form the fiber's covering. When there's enough fused soot, they turn the heat up until the soot itself turns into glass. Then they heat the glass tube enough to soften it, as well as the new glass inside. The intense heat eventually makes the tube collapse in on itself to form a solid rod. The internal structure of the optical fiber has been achieved. But it's still in the form of a big bulky rod called a preform, so the next step is to thin it out. First they separate the preform from the uncollapsed section of glass tube. Then they install it vertically into the drawing tower, which will draw out the final shape. The drawing tower's oven heats one end of the preform to 2000 degrees Celsius. The glass softens. Gravity helps pull it down, like honey dripping from a spoon. Then, using a glob of glass as a weight, they stretch the soft glass and keep stretching it until they've formed a thin glass fiber. A series of pulleys measure the tension of the fiber as it's being drawn. A special monitor makes sure the fiber's precisely the right diameter, 125 micrometers. That's about 1/8 of a millimeter thick. Then the fiber passes through UV lamps that bake on an acrylic coating to protect against dust and other contaminants. Finally, the fiber is rolled onto a drum. From here, it's either shipped out or put into a cable. Fiber optic cables are expensive to produce, but they're smaller and lighter than traditional copper cables. They carry more information, and unlike copper cables, they're immune to electromagnetic interference. They're also hard to tap without being detected. And all this is made possible by a complicated process based on a very simple principle: light traveling through glass.